Okay, so the second part of the question asks for a mechanism. Okay, so specifically we'll write mechanism. Okay. The step 1. Okay. Step 1. Your bromine is forming the radical. Okay. Okay, so when you are writing a bond, which your arrow should start with the bond, the end of your arrow is a single end arrow. It's a single end arrow because it's a radical formation. It's different from your resonance. Okay, it's a single end arrow should end with whichever your radical should end with. Okay. Step 2. So now I'm only write the mechanism of this major one, right? Which means I'm showing one secondary. There are two secondary hydrogen, but I'm just showing one of those. With my bromine radical. Okay, what does it work here? Okay. I'll make the bonds complete. Are people good with what we're doing now? So far, good? Okay. Are we good with this?
Yes.
Do people in the back, can you see this? You cannot see. You cannot see. Oh, okay. But, oh, okay. Okay. So if you cannot see, I'll just quickly talk through those. The part you should pay attention to is when you draw arrows, okay? When you draw arrows, we kind of like mentioned, your arrow should be single-ended. Can you see here though? Here, okay. So when you draw arrows, if you want to show, like your arrow come from different directions, it's better to show like this, okay? Or if they come from the same directions, okay? It's better to show this, okay? So that's the two way of drawing this. So you can see the same goes to if you want to go other side. It's also so that's when your radical came from two different places, okay? When you want to break a bond, okay, when you want to break a bond, okay? When you want to break a bond, you can write this way, or you can write this way. Okay, it's just like if you go with those, you should be fine with arrow pushing. But your TA will be a strict one if it's single-ended. It's supposed to be single-ended because we're only moving one electron. Where in resonance, in your quiz one, that you are all testing something. Okay, let's say nitrogen here with a double bond. I just randomly make one. Okay, so it's transferring a pair of electrons. Then you should be double-ended arrow in that case. Okay, so that's the things you need to pay attention to. Okay, any questions on mechanism writing for this one? Very good. Yes.
I have a question about step 2.
Oh yeah, go ahead.
Why are we moving a single hydrogen?
Because we want to form the major. We are writing the mechanism specifically for this secondary product, and we want to form bromine here. You can also form you can also grab the hydrogen on primary, but that's not the mechanism for major product. Okay. In my mechanism writing, there's a video which I write all. I think it's the second mechanism. It says chlorination of propane, which I showed what if I just want to write the primary hydrogen. You can watch that one. That one is I write on a hard paper flashcard. So it's still on where you find my office hour video. There's a survival kit if you go all the way down. I can show you it's being written there, okay?
Can you review again really quick though? Sorry, just like how to pick the major products.
How to pick the major? Okay, so if it's bromine, you should the major should always be the most substituted one. If the most substituted one is tertiary, then the major product will be tertiary. If the most substituted one is secondary, then it's secondary. Okay? All right, if it's chlorine, we go with selectivity of what? Chlorine selectivity.
5 for what?
Yeah, okay, 5 for tertiary, 4 for secondary, 1 for primary, okay? Okay? If it's fluorine, there is no selectivity, which means fluorine will just react based on, okay, they're all 1, 1, 1 for fluorine, basically, when you want to multiply the selectivity.
Okay.
Are we good? Are we good?
So if you had written putting it on any hydrogen, it would be fine. Like if it replaced any hydrogen.
Yeah. So it's okay. Are we done with the mechanism? So I post the video. Are we done with mechanism? Okay.